Alright, let's conclude chapter 14 on circular functions. The two exercises we're going to look at is 14n, which is the general solution of trigonometric equations that will involve either sine, cos, or tangent. And then the last bit would be a 14o, which is application questions or worded problems. With a general solution, have you seen when you've seen previously, when you solve a circular equation, you usually be restricted over a smaller domain like 0 to 2 pi, and if you have, let's say, sine of x equals a certain value, you figured it out that you had two solutions. Because those functions are periodic, if you don't restrict the domain, you will have an infinite number of solutions. And I will use a visualization with the unit circle. Let's start. So let's say you have an equation, sine of x is equal to a. That value a has to be within, let me get my laser, it has to be within -1 and 1. If it was greater than 1 or smaller than -1, then this equation will have no solution. So if sine of x is equal to a, the way you would apply the general solution is you find one solution by using the inverse function. If it's a value a that is exact, you can figure out the value using your exact value table. Otherwise, you will use your calculator to estimate a numerical value. Once you have that value, you can add 2 pi, a multiple of 2 pi, because if I draw my solution, the visualization is like this. You have your unit circle, which is a radius 1. Sine is on your y-axis, so your a value will be on your y-axis somewhere here. Now, when you draw a horizontal line, it intersects the unit circle over here. That is your inverse of sine of a. That angle is your solution. Now, if I go around the unit circle, I add 2 pi, I do a full revolution, I come back here, I will come back with the same sine value a, but the angle value will have been increased by 2 pi. I can do a second revolution, and so on. I can also go clockwise. Okay, so it's going to be plus or minus 2 pi, and the n is an integer. So if you add 2 pi, n will be 1, 2, 3, and so on. If you minus 2 pi, it could be -1, -2, -3. If I extend this line to the second quadrant, I have another solution here. And that solution in second quadrant is that one. It's pi minus my solution I have over here. So if I call that theta, this one is pi minus theta. That's your solution from the second quadrant. So just apply this formula to find the general solution. All right. Now for cos, very similar. Cos of x is equal a. A again has to be between -1 and 1, otherwise the equation has no solution for x. You're going to look for a 1 value by doing inverse of cos, and due to the fact that cos is also periodic with the same period as sine, we can add a multiple of 2 pi to find the other solutions. Due to the symmetry, that equation has a solution as well in the fourth quadrant, which is that negative angle plus 2n pi. So if I draw my unit circle here, cos is on the x-axis, and I'm saying A is somewhere over here. When you draw a vertical line, you can see you're intersecting the unit circle in the first quadrant and in the fourth quadrant down here. So the first expression is your first quadrant solution, and this one with negative is your fourth quadrant solution. Okay. With tangent has a period of, so tangent of x is equals a. Now a can be any real number, because the domain for tangent is the range for tangent is R. The domain, don't forget, the domain is excluding any multiple of pi on 2. The general solution is you find one solution by doing inverse tangent of A, and you just add a multiple of n pi. So a visualization on a unit circle, remember your tangent is on that parallel line to the y-axis. So if I have A here and I draw a line that goes through the origin of a unit circle, you can see you have one solution in the first quadrant here and one solution in the third quadrant. So every time you add pi, you just you do half a revolution, you add pi again, this time you go back to the original point. There is a summary on the textbook of those three expressions, and let's apply that. All right, first one, cos of x is equal 0.5 or 1 over 2, which is an exact value. So first thing is do inverse of cos of 0.5, which is an exact value of pi on 3. Okay, and from that you're gonna get two solutions. The first quadrant is pi on 3. Hang on, I don't need to write anything. The first solution is pi on 3 with a positive plus 2n pi, and the second solution in the fourth quadrant is negative pi on 3 plus 2n pi. And then they kind of simplify that to make it nice and tidy. You don't have to. I think this one is, at this stage, as you're learning to apply those expressions, this is the final nice solution up here. If you're confident with simplifying your fractions, this is another way or equivalent expression. All right, part B, you have tangent. Now the left hand side is 3x, so first you're going to solve the right hand side. So it's 1 over root 3. So you do inverse tangent of 1 over root 3, which is an exact answer, pi on 6 plus n pi. That's the extension. That gives you the general solution. The left hand side is 3x, and what you do is you simplified by making x the subject, so you divide by 3, and you will get pi on 18 plus n pi over 3. So another way to write this, so you're going from here down to here, you will divide by 3, you will get pi on 18 plus n pi on 3. So this expression, once you combine it as a fraction over 18, you should get the same equivalent answer. Alright, with the last one, 2 sine of x equals root 2. Make sine of x the subject, which is 1 over root 2 or root 2 on 2. When you do the inverse of 1 over root 2, it's an exact value of pi on 4. And then you apply the formula, you're going to get two solutions. The one in the first quadrant is pi on 4 plus 2 n pi. So that's your quadrant 1. The second solution, which is in quadrant 2, is, they kind of make it fancy, but let me rephrase it the way I did it. It's going to be pi minus that pi on 4, then plus 2n pi. And that expression, when you simplify, they regroup the pi terms together, they factorize it, they end up with pi plus 2n pi is the same as bracket 2n plus 1 pi, and you get the negative pi on 4 on its own. So they kind of done a fancy way to rewrite this, but if you apply the formula that I introduced in the first slide, this is a good way also to rewrite this. What I would have done also is instead of regrouping the pi term, I could have just evaluate pi minus pi on 4, which is 3 pi on 4 plus 2n pi, which is also an acceptable answer. So down here they made it a little bit fancier by regrouping as a fraction over 4. You can have an equivalent one. Alright, so that's it for 14n with the general solution. Let's move on to applications. Alright, so with this one, it's example 33. It's quite worded. I would suggest to pause the video, read the question, all the questions, and highlight or annotate the important information for each different parts. It's a lot of information, but it's scaffolded, so part A is kind of easier, and as you move down to the last part E, it gets a little bit more challenging. Alright, part A is about graphing this function. Any function that you need to graph, determine domain, range, and because it is a circular function, find out the period. So the domain is from, it's been restricted, it's an implied domain from 0 to 24. The range, due to the amplitude here of 4, is going to be from negative 4 to 4. And for the period of that function, you have a coefficient pi on 6. If you do 2 pi divided by pi on 6, that should give you 2 pi. That should give you 12, I think. Yep, so the period is 12. What's the unit? It's in hours. So the period is 12 hours. Because it's 12 hours and you need to draw it, to graph it from 0 to 24, you need to have 2 periods or 2 cycles. So let's have a look at this one. So from 0 to 24, that's the domain. The range goes all the way to from negative 4 to 4. The period is 12. So from 0 to 12 you have a full cycle, and then you repeat the cycle. The starting point is 0 because sine of 0 is 0. And then you need to remember how to draw your sine function. You can use your class calculator, but again, there's something that you need to be able to graph or sketch manually with on pen and paper. Okay, from the graph, you can answer the part B. So when is the high tide? So the high tide is going to be 4, but when is it happening? So you need to find the t value. So it's solving a circular equation here. You make sine the subject. You find out that you have 2 values. So the first one is at 3 a.m. and the next one is at 3 p.m. or 1500. Okay. Next one. What was the height of the high tide? So I already answered that part. It's going to be 4 meters because that's when you need to make the function equal to. Then what was the height of the tide at 8 a.m. So make sure that your 8 a.m. corresponds to t equals 8. Once you double check that, you substitute into here and you evaluate your height, which is a negative value, which is fine. Leave it as an exact value, but don't forget to add the unit, so it's in meters. So it's going to be negative 2 root 3, or if you write it in a sentence, because it's negative, you can remove the negative by changing your sentence to indicate that you are below the mean height, or when h equals 0. Alright, with the last bit, it's going to be solving you're going to use the general formula. So it's crossing, you need to figure out the t value when h equals 1, which is 1 meter above. You make your equation assign the subject, so that's going to be a quarter. You use your calculator to evaluate inverse of sine of 1/4. Let me get a pen. So to get the first answer, it's inverse of sine on your calculator of 1/4. Okay, so that's the solution you get from quadrant 1. To find the next one, that's quadrant 2 for sine. That's quadrant 2, so it's going to be pi minus that answer. And then the next one, it's due to the period. You add a period, you add 2 pi. So from the first to the third, you add 2 pi, and the second to the fourth, you add 2 pi. Because the domain is it says on January 1st, so it's the first day, so you have to restrict it within that day. When you have those 4 values, remember the left hand side has pi on 6 times t. Rearrange it to make t the subject. You find the values are from 0.4 up to 17.5. You can't have any more because that goes on to the next day. Okay, that 0.48, you need to convert it into hours and minutes. So that gives you your 29 minutes after midnight. This one is 5 hours. Now, how do you convert those 0.51 and so on? You multiply by 60, the decimal part. You're going to multiply by 60 and you round it off, and that gives you your minutes. Okay, so 0.51 times 60 is going to be close to 31. Okay, once you have found the height, so let me do a visual. So if you have your 1 meter, it's going to be somewhere here. If I draw a line like this, the first time at 29 minutes after midnight, it's happening here. That's the first occurrence. The next one at 5:31, it's down here. 12:29 is over here, and 5:31 p.m. is down here. So you can see that between those 2 times respectively, the tide is higher. So the boat is able to pass the harbor between those 2 times because the tide is going to be higher. So it's going to be between those 2 times, which is up here. And then the next 2 times between 12:29 and 17:31. That's the next interval of time where the boat will be able to get into the harbor because the tide is high enough. So just be careful read the question carefully. I like to use the graph as well, the sketch, to get a good visualization about the situation, and that allows you to hopefully to answer the question. So go through the other work examples for you to be able to get through the application questions. And that's it for 14.0. end the whole of chapter 14, and I see you in the next video.